Hello students, today we will solve one problem. Uh, this problem is from NCERT book. It's an example 2.9. This problem is basically based on capacitors. The problem is like this. A network of 410 microfarad capacitors is connected to a 500 volt supply as shown in the figure. Determine A, the equivalent capacitance of the network, and B, we have to determine the charge on each capacitor. Note the charge on now capacitor is the charge on the plate with higher potential equal and opposite to the charge on the plate with lower potential. So the problem is like this. Now we will proceed for the solution. So here in the part A, we have to determine the equivalent capacitance of the network. So if you will see the figure carefully, the capacitors C1, C2 and C3, they are placed exactly one after the another. So they are in series combination. Okay. In series, the components must be placed one after the another. So C1, C2 and C3 are in series combination. So first we will calculate equivalent capacitance of C1, C2 and C3. Okay. So now we will proceed further. A part. If we have capacitors C1, C2 and C3, so equivalent capacitance in series combination is given by 1 upon C is equal to, I am denoting by C dash is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Here 1 upon C dash is equal to 1 upon 10. C1 is 10 microfarad and C2 is also 10 microfarad and C3 it is also 10 microfarad. And so if we will simplify this, it will become 3 by 10, and if we will further simplify this, it will become C dash is equal to 10 by 3 microfarad. So we have got capacitance C dash, equivalent capacitance C dash of C1, C2 and C3 in series combination. Now if we will see figure carefully, uh, we have to determine the equivalent capacitance of the network. So we have got equivalent capacitance C dash of C1, C2 and C3. Okay. Now C1, C2 and C3 and C4. Okay. Here C4 is in parallel with C1, C2 and C3. Just see this figure because C1, C2 and C3, they have this positive and negative, and C4 is also common positive and negative end of the potential. Okay. So their potential is same. In parallel combination, there is same elect potential difference. So C4 is in parallel with C1, C2 and C3. So we will calculate equivalent capacitance. Okay. So if we have two capacitors and we have to determine the equivalent capacitance, and the condition is that the two capacitors are in parallel combination. So their equivalent capacitance becomes simply C is equal to C1 plus C2. Okay. So now we will proceed further. So here we have two capacitors and we have to determine the equivalent capacitance. Okay. So here we have got the equivalent capacitance of C1, C2 and C3, and it is in parallel with C4. So equivalent capacitance will become C is equal to C dash plus C4. Okay, so now C is equal to C dash is 10 by 3 and C4 is 10. They both are in microfarad, and if you will simplify this, it will become 40 by 3 microfarad. So we have got the equivalent capacitance of the network, and it is equal to 40 by 3 microfarad. Now we will see B part. In B part, we have to determine the charge on each capacitor. As we will see clearly from the figure, C1, C2 and C3, they are in series combination, so their charge is same, and if charge is same, current is same, because there is only one common path for the current flow. Okay, so here charge is same. Okay, now if you will further analyze this figure, AB potential difference across AB is, if we will determine potential difference across AB, it is equal to Q upon C1. Okay, across AB. And across BC is Q upon C2. And across CD is Q upon C3. And across AD is Q upon C4. I am denoting by Q dash upon C4 because it is in parallel with these series capacitors. Okay, in parallel combination charges are not same, charges got get redistribute themselves. Okay, in series combination only charges are same, in parallel charges are not same. So I am using the different notation for capacitor C4. Okay, so we will proceed further. Here there is also one important thing, there is also one important concept in series combination, and this is, we will see in series combination. There is also one important, very, very important concept, and this important concept is in series combination. In series combination, total energy supply is equal to energy used by individual components. Okay, here total energy supply is V, that is our voltage supply, and it is equal to 500 volt, and it is equal to V1 plus V2 plus V3. Okay, that is across capacitor C1, C2 and C3 we have V1, V2 and V3. Okay, and it is equal to 500 volt. Okay, and V1 is equal to Q upon C1. V2 is Q upon C2 and V3 is Q upon C3. So now there Q C1 is 10 microfarad, 10 microfarad and 10 microfarad. It is equal to 500 volt. So it will become 3Q by 10 is equal to 500. And if you will further simplify this, 3q will become 5000. Okay, and q will become 5000 by 3, and was in microfarad, so it will become 10 into 10 to the power minus 6. Okay, and if you will further simplify this, it will become 5 by 3 into 10 to the power 3 into 10 to the power minus 6, and if you will further simplify this, it will become 5 by 3 into 10 to the power minus 3, and if you will further simplify this, it will become 1.66 into 10 to the power minus 3 coulomb. So we have got our charge Q as 1.66 into 10 to the power minus 3 coulomb across capacitor C1, C2 and C3. Now we will see next part of the problem. In next part, so now we have got our charge Q across C1, C2 and C3. Now we will see our charge across capacitor C4. Okay, I am denoting charge across capacitor C4 as Q dash. Okay, I have told the region in previous concept. Okay, I have already told you the reason why I am using charge Q dash across capacitor C4, because it is in parallel with C1, C2 and C3, and in parallel combination charges redistribute themselves. Okay, charges are not same. Okay, now so now here, if we will proceed further, if you will see the end AD. Okay, so there is a potential difference across AD, and it is equal to, that is potential difference V4 is equal to Q dash upon C4. Okay, and it is equal to 500 volt. So now from this equation we will calculate our charge Q dash. So Q dash upon C4 is equal to 500 volt. So here Q dash is equal to 500 into C4 is 10 microfarad. So it will become 10 into 10 per minus 6. So Q dash will become 5000 into 10 to the power minus 6, and Q dash will become 5 into 10 to the power minus 3 coulomb. Okay, so we have got our charge Q dash as 5 into 10 to the power minus 3 coulomb. So this is the solution from my side. So this was very interesting problem, and this problem we have to determine the equivalent capacitance across each network and charge, and there was a concept of series and parallel combination. So this is the solution from my side. If you like my problem solving technique, then please like, share and subscribe my YouTube channel. That's all. Thank you.